I know that you are all really busy people as faith leaders, and so I do appreciate your carving out the time for today and for the five other sessions that we'll be having on this topic of faith leadership in the context of climate change. A lot of opportunities, a lot of challenges in this new context of our changing climate. So for this first session, we're focusing on better understanding climate change as the context in which we are doing ministry. And to help us understand the science of climate change, its causes and its impacts, as well as what we should be doing about it, I'm delighted that we have with us climate scientist, Dr. Leigh Stearns. Dr. Stearns will be speaking for about an hour, maybe a little bit less than that, and then there'll be an opportunity for all of you to raise questions that you may have regarding climate change, because it's such an important it's important to understand the science behind it so that we can speak somewhat confidently in leading our congregations and faith groups. So during the presentation that Dr. Stearns will give us, feel free to write questions in the Q&A, and yeah, it's there. And then we'll gather those at the end. And also, I would encourage you maybe not to use too much of the chatting. Put your questions in the Q&A, then we'll have them all together. And don't chat too much, because I found it's often hard to pay attention to a presentation and be chatting at the same time. So maybe you found that too, or maybe it's my age, I don't know. But encourage you to kind of focus on what's being presented while it is being presented. And then we'll have time for questions afterward. Dr. Leigh Stearns has a PhD from the Department of Earth and Climate Sciences at the University of Maine. She is currently professor in the Department of Earth and Environmental Science at the University of Pennsylvania. Previous to that, she was associate professor at the University of Kansas from 2009 to 2024. During which time she attended Plymouth Congregational Church in Lawrence. For those of you who are more Kansas City related, you understand those places. Her research specializes in studying glaciers, their changes, and the effects in both Greenland and Antarctica, and has a substantial number of publications related to this. We are fortunate that she is also very interested in climate education and literacy for all ages, and so she agreed to be our seminary's climate scientist advisor through the Climate Science and Theological Education grant that we received from the Dialogue of Science, Ethics, and Religion project. And so she agreed to speak with us today. So we are delighted to have her here to speak to us, and we are looking forward to that. And again, I want to invite some of you who have entered in. I want to welcome you to the space to say I'm really delighted that you have chosen to spend your time with us as we explore faith leadership in the context of climate change. So Dr. Stearns, please share with us some of the science and all that you have to share.
Sure. I know Ruth said it's distracting to have questions in the chat, but also if I'm talking about things I'm using a term that needs clarification, I don't mind being interrupted or just pipe up. So I'm learning how to better communicate the science, and I'm eager for any questions that you have, and we'll have time definitely to go through some of the more detailed questions at the end of this discussion. So I echo what Ruth said. I really appreciate you all taking the time. Everyone is so busy to listen to what I have to say, and hopefully it helps you be more informed in having conversations or leading discussions in your various positions. It's so nice to see people from areas where I have studied in the past. So, I, as Ruth said, well, I grew up in New York City. I went to St. James Episcopal Church as my home church. And then I was at the Ohio State University. I went to Trinity Episcopal Church. Then I was at the I went to Carleton College in Minnesota, but I I didn't have a home church during undergrad. Um, University of Maine. So I see someone was from Belfast, is in Belfast. So I was at a small church, also Episcopal church in Maine, and then in at Plymouth in Lawrence, Kansas, and now I'm at the University of Pennsylvania, finding my home church here at the same time. So I bounced around a lot, as I think many of us have, and finding different churches in these journeys has been an important part for me. So today I want to give you a little bit of an outline here. This is me. I do glaciology, so I'm studying how glaciers and ice sheets are responding to climate. I was at the University of Kansas, as Ruth said, from 2009 until last year. And so as I'm shifting to a new position here, and kind of given the current political climate of everything, it's been a real time for me to reflect on how I'm communicating the research. How is the research I'm doing actually helping people? And are there ways that I want to shift kind of how I'm doing my research? So it's been a big time for reflection for me too, and how to communicate better. So today I want to talk about kind of how our climate is changing and why it's changing, and then give you a little bit about my perspective of why I'm concerned and why this is a concerning issue. I'll talk a bit about my own research, just to give you a little context of how glaciers and ice sheets are changing and why it's important, even in Kansas, everywhere. And why it's important for us to be having these dialogues in faith environments, in those kind of safe spaces that people have and can kind of bounce ideas off of. So climate is changing, and it has changed a lot over the geologic past. To put it in context, so in this graph is 20,000 years before present and today. 20,000 years ago, we had a kilometer of ice over most of North America, and it was about 5 degrees Celsius colder than it is now. So when we talk about, I always put this plot up because I think it's important to know, yes, we know climate has changed a lot over the past. That's not new. But to put in some perspective of how the current change relates to some of these past changes. And so we are looking at, probably committed to being at 1.5 degrees above this kind of average here. If worst case scenarios come true and we end up, much higher than that, that's, about the time or about the range of changes that have taken place in last glacial interglacial cycles. So 1.5, half a degree of warming is a lot. Half a degree of warming in any given day doesn't feel like a lot. If it's 80 or 81 degrees, those don't feel the same, but this is a global average over an entire year. And so we're putting it in that context, averaging it and integrating it over this big area and over a long time. That means a lot of changes, and it represents itself in different ways in different areas. So what a lot of protests and kind of attention has been paid to is keeping us below 1.5 degrees warmer than this average that we're used to. Last time we were 2 degrees warmer than today, sea level was 25 meters or 80 feet higher. That was the last interglacial at 125,000 years ago. So when we think about kind of our most recent past of being as warm, our environment looked very different, and we didn't have our whole societies, built on the kind of stable time period that we have now. So that's a little bit of context. We know, just to kind of put this 20,000 years throughout geologic time, we've had these huge swings in temperature. And on this axis, the x-axis is a little bit confusing because at every double hash mark, it changes the scaling that it's going by. So here's 20,000 years ago, and then it's jumping by 200,000 years at a time. And these are our big glacial, interglacial cycles, which this was the last time when it was as warm as today and when sea level was 25 meters higher. And so we know we've had these big swings in the past, and we know we've had time periods when it was really, really warm and we had no ice sheets, and everything was kind of like this hot house, and we had different animals living everywhere. We had kind of, crocodile-like things in Antarctica and marsupial things in Greenland and things. The whole environment was very different. Um, so one important piece that I'll kind of keep coming back to is that, yes, climate has changed in the past. We didn't, have the communities that we have that are in they're in very vulnerable positions, relying on the infrastructure that we have now, and that the rate of change that we are seeing now is much faster than it's been throughout geologic time. And so, in the past, kind of, we look at all these cycles and we look at how quickly it goes from cooler time period to a warmer time period. It's taken about 1,000 years to warm 1 degree Celsius. So 1,000 years to warm at about the level we're looking at now in 20 years. And so doing these changes very quickly is hard for every living thing. Essentially. So it's not just the swings, but it's how they're manifesting right now that's very different from the geologic past. And that's an important piece. Okay, so that's the first part. Change is happening and it will continue to happen. The current changes are big. So this is just kind of looking at these averages and in a spatial sense, and where it's red, it's been warming during this time period, 5-year average, and where it's blue, it's colder. And a lot of our kind of recent past, when we've been able to measure it, we've seen it kind of, oh, warmer here, colder here. It's been kind of balanced. And you can just see as time is progressing that the warming we're seeing now is pervasive and unequal. So when we talk about a global average temperature of increasing by 1.5 degrees, that's everywhere. That doesn't mean it's only 1.5 degrees everywhere. That means 5 degrees in the Arctic and maybe 0.5 degree in certain parts of the ocean. And in certain places, it's a lot warmer. So climate change is inequitable on many different fronts, and where it exacerbates, it's not a heterogeneous, or it is a heterogeneous change. It's not homogeneous globally, and that's just a really important part to keep in mind. And it's especially harder in places that maybe are less resilient. And so even if, in Kansas, we might not feel that much warming, doesn't mean that warming is not taking place in the Arctic or in parts of Africa and parts of Europe. So keeping that in mind is also another big piece. This is another, I know there's a lot of graphics and stuff, but so many of the climate visualizations I think are so good that I just can't help but to show them. This one is showing for every month, like how has that average temperature changed? And so you can see it going out, but also the changes every month. So it's not just it's the winters are warmer or the summers are warmer. It is, kind of globally averaged. Each month is also feeling that change. And so, all this evidence just kind of highlights the signal to noise ratio is getting a lot better. A lot of this stuff was theorized 100 years ago. We started seeing evidence of it, 50 years ago or so. And now we're like, really, the evidence is very clear that the climate is changing. And again, the climate changing by 0.5 degree has really serious impacts for a lot of communities. That means, increasing the amount of heat waves, decreasing the amount of fresh water. This website kind of lets you parse out different parts of the world and look at what does that actually feel like in that community, because it's a complicated issue, and we'd like to describe it as climate being a threat amplifier. Whatever a country or a region is dealing with, whether it's floods or drought or water availability for agriculture, climate change is kind of making that issue more prevalent. And this is why Department of Defense cares about climate research in their own way, because they want to know where next wars are going to break out, where people can be fighting over water or food or things like that. Like There at a lot of levels, people are paying attention to climate science, insurance companies, people predicting technology, like all the people that maybe we are thinking might not care about climate. They care about climate in their lens, but maybe they're not connecting it with the bigger issue. So whatever kind of front their perspective they're coming at it from, it is impacting a lot of different things. Um, so I said before that the current changes are big and uneven. And so in particular, where I study, I do a lot of my research in the Arctic. It's changing the most. And so you might wonder, well, why on earth is the Arctic seem to be one of the big harbingers of change here? And that's because in the Arctic, we have a lot of sea ice, and sea ice is very reflective. It reflects the 90% of the incoming solar radiation when you have a lot of sea ice. And sea ice is just the frozen top of the ocean. So it's fresh water. When it forms, it pushes out a lot of salt. So the Arctic Ocean is also quite salty in compared to other parts of the ocean. And when it's healthy and extensive, it's reflecting a lot of incoming sunlight. But when we're reducing that sea ice or forming a lot of melt ponds on the surface because temperatures are changing, now that sea ice, instead of being a bright white reflective body, is absorbing that heat, and that's what we call a positive feedback because it's just kind of snowballing that impact. It makes it worse, it makes it warmer, and then it's absorbing more, and then it's warmer and there's less sea ice and it's absorbing more, and so it amplifies the initial response. And we're seeing that a lot in the Arctic, whether it's sea ice or snow cover or the ice sheets changing, we're replacing something very reflective with something dark that absorbs and traps that heat. And so that heat stays on Earth there. Many of the changes that we're seeing are taking place in the ocean. The ocean is absorbing a lot of that heat for us right now. And 90% of the warming that has happened over the past 50 years has been in the ocean. And so when we kind of think about how the Earth's energy balance has changed, the land and atmosphere and ice heating, that has increased, that is increasing over time, how much the land is absorbing and our atmosphere is absorbing, whether it's 1.5 degrees or 2 degrees Celsius. The ocean is taking up the bulk of that heat right now. And so that's what's being shown here. And the reason we don't talk about it is that we don't live in the ocean. So we don't, it's not the narrative that we're talking about when we're talking about agriculture and things like that. It comes out in, diversity of fish and ocean. The ocean takes a long time. Those currents are very slow, thousands of years. And so we don't always see this as reflecting on something that we feel day to day. So that's an important aspect is that, and I think why climate change also has a hard time resonating with people is that we're like, well, we don't see I'm not feeling the change right here, right now. Does not mean that the change isn't happening and will impact other people and us in the future. And this is this very funny cold blob in the North Atlantic Ocean. So there's one, and that's due to kind of how our circulation is changing over time because we have less sea ice being formed, and then the ocean isn't as salty, and so that overturning current has changed. And in that one spot, it's getting colder. But if you look everywhere, pretty much everywhere else, those oceans are getting warmer. And it's not just the surface of the ocean, but even at like 800 meters depth, those temperatures are changing as well. Okay, so how do we translate this to how we're feeling and how it might kind of project in the communities we live in? There's another great website of what will climate if we kind of continue on the track that we're on right now. What is it going to feel like in 60 years? And Kansas City, in terms of precipitation and humidity and temperature, is going to feel a lot more like, this town in Texas. And so if you kind of think of what plants they're growing there, what water issues they're dealing with, what energy uses they're dealing with in terms of air conditioning and stuff like that. Those are the shifts that you see. And you can, do this for a lot of parts of the world to just kind of help make it more tractable of how your particular community might feel. Going back to kind of the changes, the way climate presents itself. Another part of the narrative, global warming is not the best term. We often focus on temperature because it's the easiest to measure and it's the one that people can feel the most. When you talk about precipitation or humidity or other ways that climate is changing, it's a little bit more complicated. And so for a narrative and a conversation that way we've kind of framed it all in temperature. But in many ways, dealing with changes in precipitation is more harmful. We want the rain when we want it at the amount that we want it. We don't want it more or less in those moments. And in many cases, the predictions and what we're seeing already is that we're going to have more kind of like the storms that come will be more intense and the droughts that come will be more intense. And so that kind of variability is very hard, especially for vulnerable communities to deal with. And in terms of growing things, we don't want a ton of precipitation. We don't want floods and drought. We want kind of the nice steady ability to irrigate and things like that. So if you were going to take this region and say, oh, well, the average in this region by mid 21st century is 0. Yeah, it's a way that it gets summarized. And that's kind of some of the way that averaging global temperature washes out the variability that is really hard to deal with. And so it's really important in the climate narrative to focus on the local and what those changes might look like locally. So these are just under different SSP is the socioeconomic pathways of kind of the intermediate scenario of emissions and very high scenario of we're not embracing renewables and we're kind of not embracing new technology, but emitting more. These are these two different scenarios. So my fourth point, hopefully you've gotten a little bit of a sense of the changes are big, they're heterogeneous. Precipitation is very important in concert with a lot of other variables, but one that kind of gets underestimated. And my next point is that everything's connected, and you might already know this, but it's a good reminder that Earth systems are connected, and they're connected in ways at different time scales and in different ways. But if the ice sheets are changing, that changes the currents. And if the currents are changing, that changes the way weather kind of propagates around the world. And that impacts, the built communities on land. And so while we might not see the next day a reflection of how Arctic sea ice impacts, farms in Kansas, we'll probably see that, over a trend of time, 10 years, because it impacts how the jet stream travels across the world. So yeah, and this has been studied. The way these are connections has been studied kind of in depth by your scientists for a while. There are, pieces of it that make the science really interesting that we're still learning. Oh, you do this and it impacts that because our models are getting better and our observations are getting better. But the framework of how these systems are connected has been studied fairly robustly, including what drives climate. And so we know the drivers of climate change very well. There have been kind of theoretical frameworks for a while, and then observations, in the lab, and then in real life of how carbon dioxide and greenhouse gases impact the atmosphere. And I know this didn't copy very well, but it's still one of my favorite schematics because it just shows the different levels of things that are impacting climate. And so we know that, yes, the Earth-Sun geometry is really important, and that There's a periodicity to the distance between the Earth and the sun and the tilt of the Earth on 100,000-year timescales, and we can predict that really well. That's what's driving our glacial interglacial cycles that I showed on the second slide. You could see that there was some sort of pattern there, and that pattern of hot, cold, hot, cold, hot, cold is driven by the Earth-Sun connections and geometry, and that was discovered in 1940s by this Polish scientist Milutin Milankovitch. And right now, it matches our climate cycles really well. Right now, we should be cooling based on the Earth-Sun geometry. We are in a cooling phase. So, and I don't know if you remember, there were some headlines, I think, in the 80s, or if like scientists predict like global cooling and therefore they don't know anything because it's warming. Was kind of one of the original attacks on climate science. And yes, like if we take out all human impacts, we should be cooling. The fact that we aren't is more evidence that we are driving some of these changes. We are driving the changes that are taking place. Solar output also has been explored very intensely. We know that the sun is very dynamic and has solar flares and its own periodicity to it, and we can measure those fairly well. And sometimes they are correlated, but in terms of long-term trends that we're seeing in the climate cycles, that's not a driver. And then we have, atmospheric reflectivity, how are clouds reflecting incoming sunlight? What's the composition? What are greenhouse gases like? How are they likely to change? Land factors, forests, their role and how that land use is changing, the surface reflectivity of like sea ice and those things. We can constrain these pretty well in our models. Yes, there are uncertainties, but on a large scale, the models of temperature change and sea level rise that were developed 50, 60 years ago capture all these processes at a level that's predicted what we're seeing now. And then there are tectonic factors. When you have a volcano, it reflects incoming sunlight, and you can get global cooling for a year or two. And then where the placement of the continents in terms of where they are and how they're disrupting ocean currents play a role. And those can be mapped out, if you're looking at climate change in the geologic past. So we know all these variables quite well. And in fact, this is a projection that Exxon put out in the 1970s of kind of how much carbon dioxide is in the atmosphere and how much warming that's gonna be over here on this other y-axis, and then what year. And they haven't been so off. So people who know, who have been thinking about this for a while, the science has been there, the main physical drivers have been there, and we're following the trends that were predicted by all sorts of skeptics and people who have understood this for a long time. So we know that it's not part of this natural cycle for a number of reasons. Natural cycles redistribute heat. So like a climate oscillation or a cycle that's happening in an interglacial or glacial, those happen periodically, like within our climate system, and they move heat and moisture kind of in different places on Earth. But right now, so when the atmosphere is warmer, the ocean, deep ocean tends to be colder and stuff like that. But right now we're seeing warming everywhere. And even kind of going back to that movie that I showed in the beginning, where it was like warmer here and colder here. And that's kind of like what you get in El Nino or La Nina. It's just a different distribution of heat. Now this is imprinted on top of that. And so everywhere is warming. We also know from our models, which have been, while we still improve them, they have been pretty good, again, for the past 50 years, that if we are only looking at natural causes, so this is from 1850 to 2020, the black line are our observations. So that's the data that went into making those maps of warmer here and colder here. And they have been well vetted and pretty good. The uncertainties are higher when we're thinking about going too far back. But the black line is showing kind of how global temperature has changed since 1815. We have this trend. This is the shading is the uncertainty around that. If we're just looking at natural causes, so El Nino, La Nina, volcano eruptions, the sun-earth geometry, we see the green line. That's where we should be. And if we zoomed out a lot, you would see that it was getting a little bit colder. So if we zoomed out to look at the 1,000-year time frame, it would be getting colder. But it's pretty stable over this time period. If we think of, kind of greenhouse gases and aerosols, a lot of aerosols cool the environment. So not everything we emit reflects directly to warming. Depends on the size of the particulate and things like that. So we are also emitting some things that cool. People who want to engineer our climate want to emit more aerosols to balance the greenhouse gases, which we can talk about in the Q&A, but is a way to maybe reduce the warming, but also has some very scary ethical and other impacts that make me very uncomfortable. So if we combine human and natural causes, that is the only way that we can get our observations to match our models. So we can't recreate the same temperatures that we see here on Earth without including greenhouse gases. And that, a lot of, as I say, like you would in the science world, if you could publish a paper that disproves all this, that was scientifically vetted, that could disprove kind of this storyline, you would be the most famous scientist because people want to be like, no, it's not humans, it's not our fault. But nothing can get past peer review that discredits any of this. It's been done by people who started out not believing it, and then as a Berkeley lab that tried to disprove a lot of these results and ended up just convincing themselves even more because there was no way to kind of manipulate the data or do different statistics that did not come up with the same answer. So how does this kind of impact? I'll talk a little bit about my work and why I find it exciting. Is that the cryosphere, the ice sphere, we have the biosphere and the hydrosphere. The cryosphere is the ice sphere, is integral into a lot of our understanding here. We have, and I'll use some different terminology. The ice shelves are connected to the ice sheets like Greenland and Antarctica. Sea ice is very different because it's just forming on the ocean. So it does not have it's not the child of an ice shelf. That's an iceberg. Sea ice is forming just from the ocean. And then we have glaciers on land and snow cover and permafrost, which I don't study, but I at times wish I did because its impact is so huge and it's so important. It releases methane, and also a lot of our infrastructure in the Arctic is built on permafrost. So understanding how it's changing, it's just frozen ground. If it melts, you get potholes and sinkholes, and no roads can survive, and buildings get tipped over and things like that. For the ice sheets, they are just kind of blocks of ice that are deforming under their own weight. So they're like rivers of ice. They're moving that quickly. And this is showing how they're not moving that quickly, but in that same style, how ice is moving from the center of the ice sheet out to the margins. And so they have catchment basins like a river does. When the slope is high, and gravitational forces are high, they flow really fast. If there's something slippery at the bottom between the ice and the bed, they can flow really, really quickly. And so the purple is showing very fast ice, and the green and orange is slower ice. And the fast moving ice can move half a football field a day, 15 kilometers a year. That's fast. And so if it speeds up, it's discharging more ice or water into the ocean. And if it's slowing down, it's reversing that. And from a scientific perspective, it's really interesting because neighboring glaciers that should be under the same climate forcing behave really differently. And we're interested in kind of like what's the long-term behavior? Are there thresholds that these glaciers are reaching. We know that sea level in the past kind of rises slowly and then can rise really quickly. What's causing that? And is that something that we're going to see in the near future? Um, so that brings us back to the question of sea level rise. So we do, as scientists, like a pretty good job of knowing the balance of snow accumulation and snow melt and how the glaciers are discharging ice to the oceans. And that we can show in how sea level might change under different emission scenarios. So this is low emissions and these are high emissions. And this was in the latest Intergovernmental Panel on Climate Change, which really summarizes kind of the latest research on climate change. But we have this like crazy dashed line that is what they call low likelihood, high impact storyline. And this is because some glaciers in Antarctica and Greenland seem very unstable in their current climate and could discharge a lot of ice very quickly. And as I said, we've seen this in the geologic record through sediment cores and ice cores that are showing like a rapid change in what the ice sheets are doing. When I started grad school, which, was a long time ago now, but not that long ago, the kind of mental model was that ice sheets respond slowly to climate change. We have these glacials, interglacials, and now we're seeing that actually they have changed very quickly in the past. They reached some kind of threshold. And the models predict that some of them might do that in the near future. And so how do we kind of incorporate that into our thinking and building, resilient cities and things like that. And the reason why some of them might change quickly, it has to do with kind of the unique bed geometry of certain glaciers and kind of this like runaway kind of glacier speed up calving process. Kind of when we think about how the ice sheets respond, it links back to that because we actually don't know in a lot of cases what's driving that warming. Is it the ocean or is it the atmosphere? If it's the ocean, which brings warm heat from the tropics up to the Arctic, this is the North Atlantic current. It kind of hugs Greenland in certain areas. If that warm water kind of comes into contact with the ice sheet, then it can kind of eat away at the fronts and cause those changes. But the currents are pretty well determined. It's not super likely that this current would change its whole pattern within the timeframes that we're thinking about. But the atmosphere doesn't have these kind of more distinct geologic constraints. It can warm latitudinally at different rates. Yes, they're atmospheric currents, but they are more dynamic than the ocean is. And so knowing in each situation whether Greenland in particular is responding more to changes in the atmosphere or the ocean is really important in order to refine those projections of how the ice sheet is going to respond in a warming climate. Greenland is not stable in its current climate. So it will shrink, but the rate at which it does that is something that we need to constrain better so that cities can be prepared. So we use a lot of data, and this is, fun and hard part, but it's like kind of what makes the science really fun. And I'll talk about this one using a seal to get measurements in a second. But the University of Kansas, they do a lot of airborne geophysics. So I was doing a lot of that there, figuring out you fly an aircraft with a radar on it. What does the bed topography look like? Is it very bumpy or smooth? And can that help us model the ice sheets better? We use a lot of satellite data to get ice velocity. I've done a fair amount of putting geophysical instruments out to understand kind of questions of, on a very sunny day, does the glacier matter? Or if there's a big iceberg calving event, how far upflow does the ice sheet respond? If it's a very rainy winter, does the ice sheet respond? To try to understand the physical processes with a lot more detail. But when we started, going back to that schematic of ocean currents around Greenland, we didn't know whether that warm ocean even got into those fjords. So we prioritize mapping on planets a lot more than mapping on Earth, sadly. And so we didn't even know the shape of a lot of those fjords and whether heat could get in at different depths in the ocean could get into the fjords and touch the front of the ice sheet. And several years ago, a colleague of mine, oceanographer, tagged a bunch of baby seals are easier to tag, and if ever it comes across your line of work, than big seals. So they tagged 4 baby seals, actually in Newfoundland, and they made their way up to Greenland, and they molt once a year. So in a year, these 4 seals did all these dives off of the coast of Greenland. So this is a skinny, skinny fjord. Skinny meaning, 10 miles across, not that skinny, that we wanted to, and the glacier ends here. And so we really wanted to know is there warm water offshore here? Can it reach the front of this glacier? And these seals, they dive, and then when they surface, these sensors have measured the temperature and salinity and depth throughout that profile. And this guy and his friends gave us this record of an entire year of data, and at different depths, what the temperature was like just offshore of this glacier we're interested in. Now this was, roughly 12 years ago. Now we use this as justification to get moorings in that fjord so that we can do kind of a better analysis of it. But we learned that actually in that area, the warmer waters come in the winter because of the circulation of the ocean. It's not really paced one-to-one with what's happening in the atmosphere. The deep ocean has its own circulation patterns, and that it's colder in the summer. And so that kind of helps us put that into our models. It was also a really good lesson for me as a climate scientist, how we did a very bad job coordinating with the local communities here. So in this experiment, and this getting this data, putting out the moorings, we really needed to know the shape of the fjord. Is there a big sill or a little mountain that's going to block the warm water? The warm water comes in at depth. And if there's a moraine or something in the fjord, that warm water gets blocked, and it can't, even if it's offshore, it can't come to reach the front of the ice sheet. And so we rented this guy Akalu's seal ship or seal boat. It's not really a ship. When we got there, he had 4 dead seals in the back. He's like, "Oh, let me just hose it off and get the blood out." Quite a different situation. And of course, and Akalu spoke East Greenlandic, which is different from West Greenlandic and is not a written language, and not one that I or my academic colleagues speak at all. And he spoke Danish, some Danish, which they have to learn in schools in Greenland. My colleague Fiamma is Italian, so she spoke Italian and English, and my PhD advisor spoke some Norwegian. So none of us spoke enough Danish or Greenlandic to communicate well with this guy. And we spent 3 or 4 days going up and down this fjord, trying to understand where the sills, what the topography was like underneath that fjord. And after the 4th day, we got across to Akalu what we were trying, and we could point, take the boat here, take the boat here. We got across, we were looking for hills, and he just took our map and circled. We had all these fancy Woods Hole oceanographic instruments to measure the topography. And this guy just took our map and circled exactly where all this shallow water was. And we were very ashamed that we hadn't done the science the right way by engaging the local communities. Because he had grown up in this town where he did long line fishing. And so he knew the depth throughout the entire fjord. And so that was a good lesson of, we need to be thinking about these questions in a more holistic sense and engaging local communities, and has kind of led some of my research in Greenland, but also in high mountain Asia, to start with the questions of how we're engaging with the communities, not end with those questions, which, in hindsight is very embarrassing, because of course that's how we should have been doing science the whole way, but is just not the way that our research institutions are set up. And what we did find is actually this fjord is very deep, and this warm water that's coming from the North Atlantic can get into the front of the glaciers and kind of eat away at the front. And that was really an important discovery, because we can't see a lot of this. Is the glaciers flowing from left to right here. It's 6 kilometers across. We can't see any of that. We can't see what the biggest changes that are taking place are unobservable from the scientific perspective. And so we need to kind of piece together these different data sets. Okay, I'm going to go a little bit faster here because I have a number more slides to go through, just to give you a sense of scale. So the ice is coming from right to left, flowing down here. Here's a big iceberg that's breaking off. And in this fjord, which is really enormous and dynamic, all the icebergs get kind of trapped in the front, and they're kind of jammed in there. So these icebergs are breaking off. This is all the ocean here on the left side of the screen. And this is probably, I don't know, a mile long. The scale is enormous. And iceberg calving happens in colder climates and in warmer climates. The fact of iceberg calving is not an indicator of climate change, but the rate at which it happens and kind of if it's really impacting things that are happening upflow is the big question. Does the entire ice sheet care about this calving event? And if so, at what kind of response time? You can kind of see on the side here, like where the rock changes color a little bit. And that's what it's a little hard from this angle, but that's kind of like a bathtub ring of past ice. So the ice not so long ago, or there would be vegetation here, was this thick. And so that's happened in the past 30 years. So not only is it changing side, but it's kind of it's deflating. It's getting a lot thinner. And we've got better tools now to understand those changes. This is kind of another, we put out a lot of GPS, just like you have in your car or in your phone, but at higher precisions. And we're trying to put them out on this very crevassed surface to understand how the glacier adjusts to changes at the front or to changes in weather. Here's another big calving event. So all these are icebergs out here and the glaciers draining from the right towards the left. So it happens slowly and then fast, and getting the observations to measure that, even though it's a big change, it happens really quickly and we want to understand the cause and the effect. And these are just some other pictures, just kind of showing how hard it is to put instruments out on a surface that changes a lot. And while we rely on remote sensing to kind of satellites to kind of understand some of those changes. Just some more instrumentation. So all of these kind of understanding the processes, we hope, is helping us understand how likely this low likelihood, high impact storyline is. How sensitive is the glacier really? These specific glaciers that are very huge, how sensitive are they to these forcings, and what are the forcings? Does it really matter what the ocean is doing, or what are the atmosphere is doing, and at what kind of time frame and scale are we looking at? And that motivates a lot of my research. But the biggest predictor of the future is not really what the ice sheet is doing. We kind of know that those responses pretty well, but it's us and how much kind of carbon dioxide we are releasing into the atmosphere. So this is showing kind of over time on the x-axis, and the different pathways. Each pathway is a different, embracing different technology, population. And in order to keep things from going up here with huge emissions, we need to not only be curbing our emissions, but have some way of pulling out CO2 from the atmosphere. And for the first time ever, we know most of the technology to do that. I feel like when I started grad school and people were like, well, what are we going to do about climate change? I'd be like, renewables, but like they were expensive and not that well developed. And the pathway to embracing renewables was harder to imagine. And now they're cheaper and more pervasive, and we're seeing all these benefits of them. And that path, for the first time ever, which I think is really exciting, it seems possible, maybe not to be 100% renewable, but to be more renewable and less oil and gas dependent. And that is a very exciting time to be in. The pathway is not impossible. It's just politically hard right now. The technology, all the kind of resources to do it is doable. So the other thing is just that we need to talk about it, and that's why I'm excited to be here and to try to help you think of how you can talk about climate change more in your communities. Um, there's a lot of, I think, when people start having the conversations, they have a lot of interesting perspectives and things to share. But we are lacking in what I feel like lacking in the safe spaces to engage in those conversations. And that's why your communities are so important is, people show up, I think in good faith and with liking their neighbor and without wanting to fight about everything. And that's a great place to think about your perspective on things or ask questions and weigh the impacts. Most Americans, this is a great website that polls Americans about kind of what they're thinking about different climate scenarios. And there are all these pull downs of, I think it's my governor's responsibility to make policy, or I think whatever. It kind of asks a lot of very probing questions. But most people think global warming, climate change is happening. So most of these responses, with some exceptions, some very small exceptions, think it's happening. But a lot of people, aren't worried about it or don't think it's happening to them. And I think we need to kind of help people realize that it's already impacting them and people that are far away that we care about, and making those connections. Because I used to do this in class a lot of like, think of an environmental problem that you're concerned about, and then thinking of an environmental problem locally that you're concerned about. And people don't have a hard time thinking about other countries' environmental problems, but have a very hard time thinking of what's happening in Lawrence, Kansas, when you're like, why this issue is happening here too, and then they get a little bit more invested in it. The percent of adults who discuss global warming even occasionally is quite low, which I get because it's often framed in a confrontational way, or in oh, you should be doing this, or a way that doesn't maybe excite dialogue, but seems more preachy or more didactic. And that's too bad because it does pervade a lot of things, and there are a lot of things we can do, and there are a lot of interesting questions that revolve around that. And because we don't talk about it, this is kind of what I was mentioning earlier, people think it's not impacting them, when in fact it is. It's impacting prices, it's impacting, wars that we're playing a role in, it's impacting food availability and all these things, but it just seems too far away. And so if we kind of help people realize that it's already happening and it's already happening to them, that is another part of the equation I think is very important. And I think when I started, when I've given talks and stuff like that, I've always been worried, like, oh gosh, like some climate skeptic is going to come and yell at me about, some random statistic that they found about sea ice being greater in 1975 or something like that. And I was kind of nervous about that. But there are very few people that are kind of angry about it, or like flat out dismissive. And that the same climate communication website has been tracking this for the past 15 years, our perception. And the percentage that are just flat out dismissive of all climate change is actually quite small. More people are alarmed and concerned and interested in hearing more about it. And then there are a number that are like the cautious, disengaged, doubtful, are also eager to have conversations and learn more, or to think about things differently. And so I think at least I used to shy away more, because I was kind of worried about it not, just preaching to the choir or getting people who are very angry. And that's not necessarily the case. They come with good questions, and they come with things that they care about, that I can then be like, oh, you care about skiing in New England. Well, then, that climate is also impacting that. And these are some of those impacts. As I mentioned before, climate is a threat multiplier. this plot is a little bit old, but NOAA used to. I actually did not even look to see if they still make these maps. Sadly, a lot of the data that they used to compile in these nice little briefs is no longer available. But it would kind of come up with a summary of events and track, what has happened, what are the big things that people are feeling this month, and how is that related to climate? And in almost all situations, it's making whatever that country is dealing with or whatever that location is dealing with worse. And so, it's this, yeah, threat amplifier of the issue that is already hard for that community. And, churches have really, as you guys all know, been leaders in the environmental movement. Their climate connects with a lot of the values that you all are elevating every Sunday all week, of environmental stewardship and caring for others and being compassionate humans. And so there are common links and a lot of groups that are really doing innovative work in this environmental stewardship space, which of course also includes thinking about climate. The solutions are usually, right, like compatible with what we value already. It's not asking to do something that is so absurd. And yeah, kind of like regardless of affiliation, those values transcend all of them. And so, it's not something totally disparate. There was this article that came out a few months ago that I thought was really interesting about nearly 90% of US Christian religious leaders believe in anthropogenic climate change, with most believing human activity is a major contributor, yet roughly half never discuss it with their congregation, and only a quarter have mentioned it more than once or twice. And there are probably reasons for that. And I think it's useful to think of what the reasons are, and if there are ways that we as a community can help each other kind of get over that initial step, or like how are you framing it in ways that doesn't get half your congregation mad at you or disenchanted with what you're saying. And I think this is an important space to be having these conversations. And I guess finally, I'll just end with, I think this is my last slide, that the framing can be what our congregation or our friends or whoever value. And, with a lot of the things that the climate advocates are pushing forward are the things that we want anyways, and so they're hand in hands, and that makes it a hard issue, but it also makes it an easy issue. So we all want, clean atmosphere and stable climate, and not having to worry about disastrous floods happening in our communities and prices being really high and some people being really hungry because of the decisions that a few are making. So yeah, I think I'll end there and take questions. Hopefully I've given you a little bit of a flavor of what I do, and I'm happy to answer any questions that you all have.
Thank you. That was very helpful and a lot of information
A
there,
lot, I know, I'm sorry. It's a
but
lot of
really
time.
helpful
Yeah.
because everyone here, I'm assuming, are not a climate scientist. So it's really, those are things that it's not easy to kind of get the whole picture together when you're not studying that as your discipline. So now we have this opportunity to ask questions, converse with one another. And what I would suggest is that you can write it down at this point. And I haven't been watching the chat because I'm recording. I'm not quite sure how that works. But I know there is one in the Q&A, but I think it might be easier. We're actually ending up being a fairly small group on one screen. So if you want to just put your hand up, or just actually you can just unmute and ask whatever kind of question you might have. It also, well, first of all, I don't think any question you should feel like that's just a silly question. I've actually written some of those to Leigh in the past, haven't I? That like I don't understand this, even though I've kind of read a lot about it, and
It's
it probably
complicated.
is.
I can start first with Sue's question. I was just trying
Yeah.
to find like a graphic that I thought would help the most to see. Let's see.
Sue's question is explain again why we should be in a cycle of
Yes. This maybe isn't the best. I feel like I had one for teaching that was better than this one, but we have these orbital cycles that these smart astronomers figured out, 100 years ago, that our Earth changes its orbit around the sun on these very regular cycles. And so the way that the obliquity of our orbit, it changes by, a fraction. This is an exaggeration, but there are times when we're closer to the sun in this orbit, and there are times when we're farther away. That's called eccentricity, and it has a pacing of 100,000 years. That's what drives most of our interglacial cycles. And we also have precession, so kind of like the way that are we facing the sun when we're far away, or are we facing the sun when we're closer within this orbit? This is like precession of the equinox. Kind of geometry. And then we also, our Earth changes its tilt. And so you can look at patterns of this. I think there was another, sorry, Milankovitch, orbital data viewer. You can kind of, all of these happen at a very set pace. So this is one of those that's driving warmer, colder. And this is another one. And you can mush all these cycles together, and it will kind of give you a precursor of whether we should be warmer. This is watts per meter squared. So are we getting more solar radiation at on Earth during these different time periods? And we should be getting colder because of this pacing. If we smush together all these cycles, we're at a time period where we should be entering, within 100,000 years, a glacial cycle. We're in that trend. Not if all of these matched up and we were like up at the top and like, oh, all the orbital patterns say we should be warming at this pace. Then we'd have to disentangle that from what the human caused impact is. But instead, all the cycle smushing together says we should be cooler. And when we look at like ice cores and sediment cores that give us our past history of climate, amazingly, they match those orbital cycle drivers of glacial, interglacial really quite well. And so it's just like that has been the pacing for our big climate cycle. Does that help, Sue?
Yes, thank you. I'm a bit of a science geek. So as I understand it, then what you're talking about is one of those four things that you had on the chart, and this would be an extraterrestrial
Yes.
contributor to the cycles of climate change. Okay, thank
Yes.
you. I was sort of taking notes, so my bad, but you gave a lot more detail, I think. So I thank you so much.
You're welcome. And they're actually, and I'll try to remember to send it to Ruth so she can distribute it. There's a very good visualization that I think it was somebody put out where you could like change the slider of obliquity and see how that pacing changed. And because it's kind of hard to grasp all of it at once, but if you can kind of tweak each one by yourself, then it kind of helps explain it better than my words do. Yeah, Chris.
I'm in Olathe, Kansas, so not far from your former station. Our church has a fairly robust ecology ministry in the church, and one of the initiatives over the last year has begin thinking and processing our landscaping and shifting to more native plantings of prairie grasses and things that are more native to Kansas versus just putting things in that are pretty and look nice. And we have a lot of those beds in the church as well. We were having a shifting toward the native plantings. But my question that came up with, I think that's a good thing for us to be doing. But I'm also thinking with the warming temperatures, you're talking about like the Texas to Kansas kind of things. What kind of, how should we be thinking about native plantings with the shifting of temperature changes? And I know that, I don't know, just a thought entered my mind. I want to start entering a thing. We want to get all the Kansas stuff in. Well, do we need to be looking at Oklahoma prairie grasses and things like that? Or I don't know. I'm just thinking out
that's
loud a
really
little bit.
good. It's a great question because you are like doing the right thing by planting those native grasses, which are maybe not going to be so native to Kansas 100 years from now. So in terms of some of those questions, hopefully you have an ecologist in your congregation who can help more, but it does kind of raise the question of planning for these changes and building more resilient ecosystems around us. And I mean, I think depending on how native they are, like they hopefully can weather some of that variability and are not like so tied into a very small niche of precipitation and temperature. But I don't know the robustness, like how long they've been there and how many, have they weathered a very warm time period before, or are they more recent? And so, but it does raise a good point of, diversity shifts and how that gets weathered in different places. And also kind of steering your question away a little bit of the individual versus collective actions. I think anything, and that's why I always struggle with these talks a little bit, because it would be satisfying if I could give you an answer of what to do in your community. And I can't, and of course, none of us can, but I also think doing anything to start those conversations, whether it's the native grasses and why this is important, that's great. Like that, and it opens up dialogue in doing that. It's a thing, it's a tangible thing that is helping, the local habitat, and it's expressing that this is important for your congregation. And so whether it's, oh, our church doesn't use plastic straws, great, fine. Like that's all of it individually seems minor when the issue is so big, but is so important, not just for the tractable thing, but the conversation that it starts, the kind of showing that this is something you value.
Yeah, I feel like the bigger conversations are important and the smaller conversations are important, and you need to. I think there needs to be entry points into this for congregations, so there's something granular that gives them some energy of saying, yes, we're doing something, even though it's a small step. It's a step as part of a larger puzzle, and this is a piece to the big puzzle that we're being a part of in some way.
Yeah,
so
I think that's absolutely right. But and even painting roofs white and reflective, not dark and absorbing, or parking lots a color that might reflect things, like those are all things that that help. There are a lot of little things that are those entry points, but they will be individualistic for each community.
Yeah, thank you very much.
Yeah, Carolyn.
Hello, I'm Cecilia from West Africa, Liberia.
Cecilia, yeah.
That I want to say thank you very much for all that you have said, and we will take it serious to work along with it. But I have a question. My question is, from the climate change scientific perspective, what can they do to make the earth to regain its normal state? Got it?
Sorry, I didn't hear the end. Was your question from the climate and energy perspective? What can we do?
Yeah, what can you do for the earth to regain its normal status?
Yeah, that's hard. Any embracing of renewables and less dependence on fossil fuels is the right direction. And I think it's one of the things that I struggle with a lot is this climate geoengineering, because there are a lot of proposals of ways that people are suggesting we get back to a stable climate that I think are not well vetted. So emitting aerosols so that the atmosphere is more reflective. And that might mean we cool the global average temperature a bit, but your community in West Africa gets way more precipitation or way more drought. And I don't like those answers because it does not seem like it's going to be done in an equitable fashion. The only equitable way to do it is to be less fossil fuel dependent. And that's very hard in the political climate we're in, but I think it's becoming easier in the kind of technology and economic environment that we're in. The technology is there. And if we didn't subsidize oil and gas in the way that we did, it would be even more obvious that renewables are a lot cheaper. So I don't feel like I can totally answer your question, because what I would love to see is less dependence on fossil fuels, but the political powers against it are hard right now. I don't know if
I have another question.
Yes.
How can the faith community address this climate change?
Sorry?
How can the faith community address this climate change?
I think in different ways, but in also talking about it, at least, and I don't know, maybe different communities are also recognizing the connections of current climate change and, kind of their role in it, and little things that we can do. And I'm I don't live an entirely green life, so it feels a little bit like hypocrisy to say that these small individual actions matter, but I think in having a more unified voice in saying that this is really important and that it looks different in different places. I think a lot of our efforts get diminished because in one place they care about plastic waste and in another place they care about agriculture, and then we get divided in that way. And then actually we're valuing the same thing just in different communities and with different approaches, and really leaning on the similarities in our communities and not highlighting the differences becomes really important.
Thank you.
Yeah, thank you. Good question.
So you said that finally we are able to correct climate change. Didn't you say that at the end of your lecture?
We know the way to do it. There's a clearer path to do it. We're not doing it now.
And so what are those ways? I know
Embracing renewable energy. So wind and solar panels are so much cheaper to manufacture now and so much more efficient than they were 10 years ago even. But with the subsidies and kind of the dependence of our infrastructure on oil and gas, it's hard to make that shift without more kind of government involvement and shifting that balance. So it makes more sense, even economically, to be more renewable focused. Whereas 10 years ago, it seemed like just the hippie thing to say, oh, we need renewables. And everyone's like, well, yeah, but then we have to sacrifice our economy and we have to sacrifice this or that. And fortunately for us, that dialogue isn't evidence-based anymore. We don't have to make, if it's done, in an equitable way without subsidies for the oil and gas industry, then it all makes sense. But, we're not in the political environment to make those changes right now.
I know we're encouraging churches, congregations, faith groups, and individuals, to support the clean energy, do solar if you're able to. I know Carolyn actually has geothermal, I think, at her home. Support all that, but then to electrify all the machines we have in our homes or our churches that uses that clean energy, And then, also be moving toward electrification of our transportation, our cars, or maybe there's public education. That would take a big chunk of reducing our use or emitting of greenhouse gases. There's a lot of solutions, I think, but yeah,
Mhm.
they really, if you want to say down to it, wouldn't you say it would be, we need to stop using fossil fuels, keep
Yes.
reducing our usage and basically to zero to the extent possible.
Yep.
And scientists have a lot of solutions on how to do that. We'd politically be able to do it. And that's where I think faith communities, if we talk about it, we're part of hopefully engaging people so there is greater public civic and political will to move in this direction. A discouraging time right now, to be honest with you, as things are backtracking rather than going forward, but that makes the need for us, in our positions more needed.
And I feel like people, even if when they're on the other side of this issue, are kind of eager to talk about it or to, I feel like just in this past week, I've had 2 or 3 people be like, oh, is climate change real kind of stuff. And I was like, oh, are we still there? Yes, but they aren't as like confrontational or dismissive. They're more kind of curious or like, oh, I don't know, like, is this just politics? And I don't know. I just feel like I've had a number of surprising and fruitful conversations once I start having the conversation, that have been helpful. I want to answer this question in the chat or the Q&A about kind of those who bring up like God is in control questions. And I have not really had that in a public forum I feel like most of the communities that I'm talking to, I think maybe except for you all are surprised that I have, I don't bring up faith in most of my climate talks, although I do in the classroom, but maybe the students are a little bit more nervous to ask that question. But I have had it like in one-on-one of people saying, well, I think God is in control and therefore I don't need to do anything. And I usually just counter of, going back to environmental stewardship and, trying to do my part living in that faith. But I am sensitive to the fact that this might be a harder narrative for your community, or like come up with some strategizing of how you would have that conversation. It's interesting because the most parallel I have is that in the University of Kansas, the department was actually quite oil and gas discipline focused and did have also a lot of big paleontology department. And in my perspective, paleontologists are the ones that have this kind of attitude, this defeatist, like, well, everything dies in extinction cycles anyway. So it's a little bit parallel of the like, well, we do have some control in this narrative, in this space, and I want to be doing my part. But I'd be interested. I think that brings up like a very interesting perspective that I don't deal with a lot, but I'm sensitive to.
Are there other questions, or are there questions that your congregation have maybe brought to you about this? I want to mention, we'll meet again in 2 weeks and we'll have theologian with us at that point, the Reverend Dr. Greg Hunt. And that last question that was asked in the Q&A would be a great question to ask him. He'll have again a presentation, kind of an overview, kind of an eco-theological perspective, biblical, theological, ethical. But we'll have a discussion time then too. And that's a really important question, as well as a number of other ones that really keep faith people inactive. So it's here we are, faith leaders. Those would be really great things to discuss with him next week too.
I have a question if I could. Uh, Listening to and watching your presentation, it occurs to me how beautiful and complex our Earth is, and how special it is to be able to know about the Earth with all these technologies, satellites and probes in the oceans and expeditions up to Greenland. Um, and like living a day-to-day life, commuting on the bus and, being surrounded by buildings and going in and out of air conditioning. Like it's just hard to be, I would like to be more in touch with an awareness of living on a marvelous and beautiful Earth. Um, and I think uh, my question is, what do you think is good for that? What do you think helps people be in touch with that part of our reality?
A beautiful and thoughtful question. I mean, I think, a whole bunch of things of, going out in nature and traveling, all those things are, do help us. Talking to people who live in different areas help us recognize the beauty and the difference of different these different environments, and hopefully sharing how delicate and yet robust it is helps to add to that beauty. But I think it's hard, and it's such an important piece that I think I forget sometimes when I'm teaching, of being like recognize how special this is, that we have ice sheets, or like that there's this one species that relies on sea ice being this thick and its whole existence is this. Giving those as examples to people, I think are really important. And it's the kind of thing we learn often in like lower school and thrive on it, and then get stuck in, the complexities or parts that maybe aren't as thoughtful and thinking about how beautiful they are. But yeah, that's a great question, and a good thing to keep in mind, of reminding people how special it is so they want to act or they want to do what they can to keep it that way. I'm also curious, I know we have only a few minutes, but if in your kind of collective group that you have this term, if there are certain resources that would be helpful for me to prepare, or work with colleagues to pull together, that would help lower that bar of entry to have conversations for your communities, or if there's information that you think would help. I feel pretty passionate that like you guys are great conduits to engaging in hard conversations, which this has become, and that is a really important part of environmental stewardship and valuing climate and the environment. And so I want to be able to help you find the resources you need to reach your communities.
I know I had one student when I was teaching, but many of you might find this in your faith groups, communities, that when we talked about this a little bit, she said she had in her church a couple people who were climate scientists that denied that it was human caused. So I wonder if you could address the level of consensus there is on this, and why there might be some people who say, scientists or climate scientists, who say it is not human caused. It's just, natural, and therefore we cannot do anything. You addressed a lot of that, but it just kind of the level of consensus.
There 99.99% of climate scientists would give a similar talk as what I just gave. And I can probably name the 2 or 3 or 5 that disagree, and their background is not climate science. It is physics or meteorology, or they're not really grounded in the same arc that the rest of us are. And I think there are disagreements about, the best way to project land use change, or how do clouds absorb heat. There are disagreements in the nuances, but then again, they're nuances. Like the evidence is so clear, whatever metric you're looking at, that the climate is changing. And 20 years ago, the skeptic argument is that the climate isn't changing. So they're putting all their money into, oh, it's natural, oh, sea level's not rising. And now that narrative has shifted because everywhere you look, it's a different indicator saying the same thing. The narrative now is that it's not human caused, or the narrative now, I think it's shifting a little bit to, oh, we can fix it by, green coal, green whatever. Something that doesn't actually do what we're going to pull all this CO2 out, all this carbon out of the atmosphere using, coincidentally, the same oil and gas drills that we use to drill oil. So the narrative has shifted a bit. What I do with people who say it's not human cause, I mean, I guess I can ask them, like what is the indicator that's telling them that? And in some cases, they're interested in explaining. In others, it's clear it's not an argument I'm going to win, and it's not worth my time or energy, and that's fine. Like they can disagree, but usually there's something. They might not think that humans are causing climate, but they probably think that humans are polluting the rivers, and maybe there's another angle of environmental stewardship that they can get behind that actually ultimately helps climate the same way. And it's probably easier to align an action and with their values than to try to change their values if that's not something they want to be doing. Yeah. But I'm in a different space. I'm in the science space. And so, that affords me a little more impatience maybe than you all. I don't need to engage with people who are going to just argue in a not fruitful way, whereas you probably don't have that luxury. Yeah, Sue.
I noticed a lot of website references in the slide presentation. I didn't actually get those written down, but are you going to share your slides with us, Ruth? Can we get some of those?
Ruth has my presentation, so she can, I'm happy for her to share it with you all.
Okay.
If I have energy, I'll pull out the links and send those in an email. I feel like I said that I would do that for Ruth before, and I never did it. So
okay. Thank you.
Try to do that. I have not checked all of them recently. So as you know, a lot of these websites, NOAA is taking a real hit in both the satellites that it's using to acquire data and how it is communicating these results. I teach almost entirely from NOAA websites and things like that. So it'll be hard to teach without these great resources. So that's another piece is kind of the hits that our government agencies are taking right now, making it a lot harder to do this work.
Yeah, Dr. Stearns sent a PDF of her slides, so I can make that available for you. Well, we are at time, and thank you so much, Dr. Stearns, for this time. It's very helpful, and yeah, the more confident we can feel about some of that, an understanding of climate science, I think the better position we are in to actually engage the issue within our faith communities. I want to again remind you, 2 weeks, please come back and we'll really focus on the theological and biblical aspects to it. It'll be a great time, be thinking in the meantime of those issues that all of this raises. I think climate change raises a lot of theological issues about understandings of God and church and all sorts of things. So I think that should be a very fruitful discussion. And also, I just do want to remind you that we are the Buttress Center, Central Seminary's Buttress Center is sponsoring a climate conference on Saturday, September 20th. It's in person here in Kansas City, Missouri, but it's also a live stream in the morning. The two keynote speakers, one a climate scientist who's also evangelical and heads up the evangelical environmental network, and also someone who's an ethical theologian. So I think that'll be very fruitful. I would encourage, we have a deadline of this Friday for getting an in-person registration that would guarantee lunch. So my idea would think that would be one way for you to invite congregants to really get more of the climate science and the theological reflection part. It's meant for a general audience. So encourage folks you think, that could be helpful to them to either come in person, which we would love because there's energy in the room, or else to live stream if you're too far away. And I think they will be really good and supplement some of what Dr. Stearns has done here today. Those who are far away, I've encouraged pastors to, view that live stream with congregants in the room. So make it a little event that you can do together for about 3 hours on a Saturday morning. So anything else we need to say? Or again, thank you so much. And Dr. Stearns, and we will see you, the rest of you, in a couple of weeks.